My name is Stephen Gerrard, Senior Consultant at Turner & Townsend, and I'm also an accredited PAS 2035 Retrofit Coordinator and Building Surveyor as well. So today's session, like Abby briefly mentioned, we'll focus on external wall insulation and fire safety, including a review of the current political landscape. We'll also explore different insulation materials and their associated performance with fire. We'll also have a look into how this has impacted the private sector, and more specifically through the introduction of EWS 1, before finishing up with a focus on retrofit. So just to kick things off, as a sector, we know there's been many changes over the last few years that has witnessed considerable changes which have now been mandated through legislation. This includes the new Building Safety Act 2022, which aims to reform building safety legislation, including the introduction of new duties for the management of fire and building safety in high-rise residential buildings. This is one of several pieces of legislation and guidance being implemented by government to enhance building safety, which also includes the Fire Safety Act 2021. This is seen as an important step, as the Building Safety Act will help people be and feel safer in their homes, and will result in changes in the way buildings are designed, maintained and managed. A key area of focus is assuring the safety of higher risk buildings and improving the competency of the people responsible for overseeing works to higher risk buildings. This applies to new or existing occupied buildings over 18 metres or 7 stories or more, and helps clarify who has responsibility for fire and building safety throughout the life cycle. One of the biggest changes to regulations is the implementation of 2 key roles: the building safety regulator and the accountable person. The building safety regulator is responsible for overseeing the safety and performance of systems of all buildings, and have been given the powers to enforce the rules and act against those who do not comply. This role is principally aimed to secure the safety of people in and around buildings and improve building standards. The accountable person will have an ongoing duty to assess building safety risks and provide a safety case report which demonstrates how building safety risks are being identified, mitigated and managed on an ongoing basis. So how does insulation materials play a part in affecting fire and building safety? So we know that using insulation in buildings is key in reducing the amount of carbon dioxide emissions associated with heating our building stock, helping make buildings more energy efficient and reduce operational costs. However, how safe is the insulation specified in the many refurbishment projects going up and down the country right now? There are a number of variables involved, and this very much depends on which insulation materials you're using and where. And for a fire to grow, we know 3 elements are needed through heat, source, oxygen and fuel. In a building, the fuel is any kind of combustible material such as furniture, carpets, curtains, etc. And choosing non-combustible insulation reduces the potential fuel content, offering the best performance when it comes to both reaction to fire and fire resistance. There are numerous insulated cladding systems available to market, and the performance of the cladding in terms of surface spread of flame, contribution to fire growth and fire resistance needs to be fully understood when specifying a system. Reaction to fire is the material's ability to contribute to the growth of a fire by acting as a fuel source. And fire resistance is the material's ability to resist fire for a given period to prevent its spread and maintain the structure's integrity, meaning occupants can safely exit in a fire's fully developed stage. So how do we know which insulation material to use for our project? This can be difficult, can be very much a difficult decision to make, and quite often in higher risk buildings, there may well have to be trade-offs between achieving a minimum level of thermal performance and eliminate fire risk. All insulation materials are given a fire classification, which helps us to better understand how much fuel will be added to the building, as well as how a material will contribute to the development stages of a fire. The graph at the bottom shows how each classification contributes to a fire, and a majority of common insulation materials within industry have these classifications along with third-party testing and certification. As we can see, it is best to choose insulation with an A1 or A2 fire rating to ensure the highest possible levels of fire safety and to eliminate as much risk as possible. Materials that achieve A1 or A2 rating produce little or no smoke and no flaming droplets when exposed to fire. Minimum standards defined within building regulations also restrict the use of combustible materials in the external walls of buildings over 18 metres in England, and this is for buildings over 11 metres of height in Scotland. So as previously mentioned, quite often within your retrofit project, there will be a range of competing priorities in respect to levels of thermal conductivity. There may be a requirement for a certain level of acoustic performance, as well as addressing fire safety and potential embodied carbon as well. So we know that insulation in buildings is used throughout the building envelope, covering key heat loss areas such as walls, roofs, and floors. However, other key areas are required, particularly in higher risk buildings, as part of a compartmentation strategy to ensure the project has appropriate fire stopping between floors and walls, as well as cavity barriers to concealed spaces such as eaves, verges, and windows to restrict the potential spread of smoke and flame within cavity areas. A material often overlooked or missed on site, even by experienced professionals, is asbestos. However, we know this can cause devastating health problems when ACMs are disturbed and exposed over long periods of time. So to achieve enhanced performance and increased thermal conductivity values, spray foam is often seen as the go-to solution, particularly for areas such as subfloors and roof voids. However, it's important to recognise this could lead to higher toxicity with elevated VOCs, harmful chemicals, and many spray foams may still degrade and even ignite at extremely high temperatures. Many spray foams also present a considerable moisture risk to buildings, which needs to be carefully evaluated prior to its application. Non-combustible materials are the best option when it comes to fire-rated insulation, and examples of non-combustible insulation materials such as stone wool, cellulose-based wool insulation, and fiberglass, which can be manufactured into rolls, slabs, or boards. Combustible materials can also be used as part of a cladding system or within cavities around the external envelope of the building for insulation. This includes rigid foam insulation materials such as polyethylene and phenolic, which are often faced with aluminium foils. Others include thermoplastic insulation types such as expanded polystyrene, known as EPS, and extruded polystyrene, known as XPS, which are often used on low-rise projects and are generally cheaper per square metre and also offer an improved thermal performance rating. So generally, when we speak about higher risk buildings, insulation and their fire safety, this is centred around high-rise tower blocks with a storey height of 18 metres or more. As a sector, we know there's been significant focus and scrutiny on our high-rise tower blocks in response to the Grenfell tragedy, and understandably so, with many multi-million-pound remediation projects now underway to remove existing dangerous cladding and insulation systems from existing buildings. In Scotland, recent amendments to the building standards means the ruling for the use of non-combustible materials in external wall systems applies with a storey at a height of 11 metres or more. However, we are seeing more local authorities and building owners take a belt and braces approach, with non-combustible insulation being specified on buildings below 18 metres in England and 11 metres in Scotland. To give a bit of context to the scale of the challenge, there's around 10,000 tower blocks in England that still feature the similar ACM cladding system, similar to what was used as part of the refurbishment at Grenfell, rendering thousands of homes unmortgageable with significant health and safety risk. When we speak about building types, usually we define these as typologies or archetypes based on similar construction form, geometry and layout. However, when considering the implication of fire, it's also important to consider buildings in respect to their unique features, such as recessed balcony areas and access. This is important as balconies provide opportunity for fire spread across the facade. In terms of access, it's important to consider if there's any communal walkways or closes externally, and if so, what materials make up the external wall system. Are these combustible? Fire separation and adjacent properties are also important to consider and must be captured in any fire risk assessment and management plan. So there's many considerations to bear in mind when it comes to the through wall build-up. The section drawings on the slide show a combination of direct fix insulated render systems with masonry brickwork, concrete and steel frame. Many of the different components, elements and materials will often integrate with each other. So from a refurbishment perspective, it's crucial that fire risk is fully understood as part of the overall strategy. The design process will often include input from facade engineers who specialise in creating 3D models through Revit and BIM. And key areas to consider include the substrate. Is this masonry, steel, concrete, or something else? Is there a ventilated cavity? Has a compartmentation strategy been developed, inclusive of cavity barriers and fire stopping? Are you looking to introduce a range screen cladding system or facade system supported by rails rather than a direct fix system? Is there a sheathing board required to support the installation system? And quite often it will be difficult to confirm the through wall build-up, particularly of modern residential apartment style buildings, and any investigative works will rely on intrusive inspections to be 100% sure. So what is EWS1 certification? So the External Wall System 1 form process helps banks make lending decisions on buildings with potential fire risk. The form, which was introduced in December 2019, is designed to reassure mortgage lenders that buildings that are predominantly over 18 metres in height are safe and free from combustible clad materials through a standardised process. The EWS1 comprises of the outside wall of a residential building, including the cladding, the insulation, fire break systems and its fixings. Buildings requiring EWS1 forms include high-rise blocks of flats, student accommodation, care homes, as well as HMOs. The initial focus over the last few years has been in response to the Grenfell Tower fire, with the removal of aluminium composite material cladding from high-rise residential buildings, with the attention then broadened to take into consideration other types of combustible cladding systems, such as high-pressure laminate, or also known as HPL. These surveys are generally of a non-intrusive nature and require a chartered fire engineer to assess the building before giving a classification in terms of its risk. If there's any uncertainty about the through-wall construction, then some small sections of the wall system are usually cored to verify what the materials have been used. So how is all of this relevant to retrofitting buildings? So firstly, having good quality and robust data is essential in being able to proactively demonstrate compliance. If you don't have any up-to-date information from assessments across your higher risk building stock, then this should be identified as a priority to avoid increasing risk and exposure. Externally applied insulation systems have the potential to offer a pathway for the spread of fire up the outside of buildings if not adequately controlled through the design process. High-risk materials such as high-pressure laminate or phenolic are deemed non-compliant under building regulations. As a result, designers should work towards addressing the risk of fire spread for buildings in line with building regulations and best practice, inclusive of a bespoke design with appropriate construction details and drawings, as well as the provision of a condensation risk analysis and pull-out test to assess whether the building is sufficient for the system design. This process should be collaborative between system manufacturers and the project design team. Building control will also expect to see external wall systems utilised that benefit from third-party testing and certification through BBA, EWI or equivalent, and these should be appropriate to the building in scope. For example, if you're looking to install an insulated render system at a high-rise tower block, then typically this should hold an appropriate BBA or equivalent certificate that has undergone appropriate testing in accordance with BS 8414. And as a social housing provider, it's important to provide assurance to your residents, particularly in a post-Grenfell world where people might be understandably concerned about what materials are being installed to their home. Many refurbishment projects inclusive of EWI will also include other passive fire measures, such as the installation of fire doors and smoke ventilation systems. Local authorities and social housing providers will have an active fire safety investment programme, which should ideally complement a fire safety management plan, which is underpinned through a fire safety strategy, helping define responsibilities of asset, neighbourhood and housing management team members. It's crucial that as a client, you instruct people within the project that are competent, qualified and experienced to deliver your refurbishment project. And one of the key themes following the Grenfell inquiry was a lack of supervision on site and client protection. Risk mitigation can be applied through roles such as clerical works and building inspectors, particularly during construction phase, ensuring designs are consistent with the works being implemented. This is, of course, one of the many benefits of PAS 2035, which is a process designed around best practice for retrofitting existing buildings. And although the retrofit coordinator isn't expected to be a fire engineer or fire professional, they are there to manage risk throughout the project life cycle and to protect the client and public interest. This can be as simple as reviewing the design and ensuring the appropriate fire breaks are implemented, and this can be evidenced during site visits if necessary. So that brings us to the end of the presentation. Thanks very much for listening. I hope you found it useful and interesting. More than happy to take any questions that anyone has.